In the previous video, we made a shooting animation. However, it was pointed out to me in a comment that the animation lacked recoil, and I thought about it, and we're going to add recoil not only on the animation, but also as a mechanic, and we're going to replace our gun's random shooting angle with some actual weapon sway. So weapon sway combined with recoil will make our shooting animation that much more realistic and more fun to use overall. Okay, let's get started. In my player character, I'm going to click on right hand aim rig. This is where we have our multi-aim constraint. To implement recoil and weapon sway, we're going to change this offset value. So for X, if we change X, it will give something like this. So this is our horizontal weapon sway, and for the Y, it will give something like this. So it will rotate around the forward axis. And for the Z, this is our actual recoil angle. So if you shoot, the gun will do a movement like this and will return to its position. Let's go to our scripts folders, then NPC and combat. And here we're going to create a script called Recoil. Let's open the script. I'm going to use unityengine.animations.rigging. Let's have a reference to our multi-aim constraint. Let's have an onShot method that we are going to wire to the shot event on the gun in the inspector. Let's define a recoil angle and a recoil angle random. So when shooting the gun will rotate by an angle between these two. So between recoil angle and recoil angle plus recoil angle random, and we'll store that new angle in a variable. So I'm calling it current recoil angle, but actually let's call it vertical offset because this represents the vertical offset of the multi-aim constraint. In the onShot method, we're going to compute the recoil angle, which is going to be recoil angle plus random range from 0 to recoil angle random. Then we're going to add that value to our vertical offset, and we're going to set the offset on multi-aim.data to a new vector tree with our vertical offset in the Z coordinate. Let's go back to our character prefab. In the gun, I'm going to add a recoil script, and I'm going to set the multi-aim constraint to right hand aim rig. And I'm going to go into the gun script, and I'm going to add the onShot method of our recoil script here, recoil onShot. Let's set the recoil angle to 10, so it's very visible. So I'm running the game and I'm going to shoot. So the offset of the multi-aim constraint has changed, and if I keep shooting, it will keep increasing without ever going back to normal. So we need it to return to normal at some point. So we're going to use a finite state machine to manage the different phases of recoil. I'm going to use some terminology borrowed from music production. So if you've ever used a music production software like FL Studio, you'll be familiar with this. So in the recoil, we'll have an idle state, an attack state, and a release state. During the attack state is when you reach the maximum angle, and then during the release state is when you go back to normal. And this normal state is the idle state where vertical offset will be 0. So we're going to define all these states in an enum, and we're going to create a variable state set to idle by default. And let's define a change state method where we'll set the state to the new state, and here we'll implement some code that will execute when we enter a new state. So when we enter the idle state, the vertical offset will be set to 0. So we're going to define our attack and release states using animation curves and a duration variable. So let's add them here. Let's define a recoil attack duration, a recoil attack curve, and a recoil release duration, and a recoil release curve. Let's use a timer variable like we did in the procedural shooting animation. So in the change state method, when we enter the attack state or the release state, we're going to reset the recoil timer. In the update method, if we are in the attack or release state, we're going to add time delta time to our recoil timer. In the attack state, if recoil timer has reached recoil attack duration, we're going to change the state to release. And in the release state, if recoil timer has reached recoil release duration, we'll change the state to idle. In the onShot method, instead of doing this, we're going to change the state to attack, and when we enter the attack state, instead of having that code in the onShot method, we're actually going to move it to the change state method when we enter the attack state. So if we do it like this, the change will be instantaneous, and we actually want to use our animation curves. So what we can do is actually use this vertical offset as our target value that we want to reach, and we're going to store the starting vertical offset that we start with in the attack state. So let's define a variable underneath vertical offset. Let's call it starting vertical offset. So when we enter the attack state, we're going to set starting vertical offset to our vertical offset before modifying it, and we're not going to set the offset of the multi-aim constraint here. However, we'll do it when we enter the idle state. So we're going to set it to 0. So you know what? Let's rename vertical offset to target vertical offset, just to make the name reflect the actual purpose of this variable. Then when we enter the release state, we're going to set the starting vertical offset to the target vertical offset, and we're going to set target vertical offset to 0. So just for good measure, let's also set starting vertical offset to 0 when we enter the idle state. Okay, now let's go to our update method. So during the attack state, we're going to move from the starting offset to the target offset. So we're going to define a variable vertical offset, which is going to start at starting vertical offset. We're going to evaluate our recoil attack curve at recoil timer divided by recoil attack duration, and we're going to store this value in a recoil variable. Then we're going to add this value to our vertical offset. Then we're going to set the offset on our multi-aim constraint to new vector tree 0, 0 vertical offset. But before we do this, the evaluate method on the curve will return a value between 0 and 1. We need to multiply it by the actual recoil magnitude, and to obtain that magnitude, we're going to subtract starting vertical offset from our target vertical offset. Because during the attack stage, we know for sure that target vertical offset is going to be bigger than starting vertical offset. Now in the release state, we're going to evaluate the recoil release curve at recoil time divided by recoil release duration, and we're going to store this value in curve value. Then to obtain the vertical offset, we're going to use mathf lerp between 0 and starting vertical offset, and for the t parameter we're going to use our curve value. Then we're going to set the offset on our multi-aim to new vector tree 0, 0 vertical offset. Now let's go back to our character prefab. In the recoil script, we're going to define a recoil attack curve. Let's use this curve template here. So this is fine. However, perhaps we can make it reach the maximum value a little bit faster. Something like this. Yeah, something like this will do it. And then for the release curve, let's set it to this template by default, and then we want it to go back to 0. So let's edit this key and let's set the value to 0. We don't want it to be linear, so I'm going to add a little bit of sustain. So it's going to sustain the value a little bit, then go back to 0. Something like this will do. This inspector definitely needs some spaces and headers for better readability. Let's test our code first. Okay, so I'm going to shoot. So as you can see, our code works. So the gun rotates up and then goes back to 0. However, the value of the recoil angle is a bit too high. So we're going to reduce it, but at least the code is working. So we're going to choose a recoil angle, let's say 2, and a random value of 3. Now let's test it. Yeah, this seems more reasonable. Okay, now let's go back to our script. We just want to organize this inspector a little bit better. So I'm going to add a header here. I'm going to call it recoil angle. Then I'm going to add a recoil animation header above the animation curves, and I'm going to add a space between the attack curve and the release curve. Okay, that makes our inspector a little bit more pleasant to see and easier to read. So we're going to set the values of the recoil angle back to 2 and 3 because we changed them at runtime and we didn't save the changes. Let's have it at 3, and then for the random angle, let's have it to 4. Now what we're going to do is we're going to remove the randomization on the shooting angle because we don't need that anymore. So let's go to our gun script. In the compute shooting direction, we're going to comment out this code and we're going to simply return the direction. And we have a max spread angle on the inspector. So we're going to comment it out. Okay, now we're going to replace this max spread angle with weapon sway. So we're going to add a script called sway. Okay, this is our sway script. Let's define a vector tree amplitude, which is going to be set to 1 on each axis. And we're also going to have a sway speed for each coordinate. We're going to serialize both of these values. Then we're going to have a public float multiplier. We can use this multiplier from other scripts. For example, if you want the sway to be more intense when the character runs or the more you shoot. Actually, let's break it down into two variables. Let's define an amplitude multiplier and a speed multiplier. Let's define a public method getValue, and we're going to have the time as parameter, and it will return the value affected by sway. We want the offset to be such as the gun paints a figure of 8 or an infinity sign. So we're going to change the x coordinate of the offset using a sine wave, and we're going to change the z coordinate using a sine multiplied by a cosine, and this will give us the results that we want. And of course, when we compute these values, we're going to add them to the recoil value in order to obtain the final offset of the multi-aim constraint. So in our sway script, in the getValue, let's define two variables, amp and spd, for amplitude and speed, which are going to be the amplitude and speed multiplied by their respective multiplier. The x value will be amplitude x multiplied by mathf sine with speed x multiplied by time as parameter. As for the z value, it will be amplitude z multiplied by mathf sine, speed z multiplied by time. Then we're going to multiply it by mathf cos with speed z multiplied by time as parameter. Then we're going to return a new vector tree, x, 0, and z. So the y value is the value by which the gun will rotate around its forward axis. We're going to ignore it for now. We're going to test the figure of 8 first, and when that works, we're going to come back and add the y component. So this script will not work on its own. We need to access it from another script. So let's access it from the Recoil script. So in the Recoil script, let's add a reference to the sway script. In the change state method, if we're entering the idle state, we're going to remove this line. If we do this, if we set the offset on the multi-aim constraint directly, we're going to cancel all the recoil, and instead we're going to set the offset in the update method. So let's go to the update method. So in the update method, I'm going to move this variable vertical offset outside of the if statement. So vertical offset will be set to 0, and we'll use it here. So if we are in the attack stage, we're going to set the vertical offset. Otherwise, if we are in the release stage, then we're going to set the vertical offset to this value. So we're going to use this variable in both states. You know what? Let's rename it to recoil vertical offset. Then when we get out of the if statements, we're going to define a sway value set to 0 by default. If our sway component is defined, we're going to set sway value to sway.getValue with time.time as parameter. Then we're going to set the offset on our multi-aim constraint to sway value plus new vector tree 0, 0 and recoil vertical offset. Now back to our character prefab, we're going to add the sway component to our gun object. Then we're going to link it to our recoil script. Okay, so the sway is barely visible. We're going to increase the amplitude a little bit. So the amplitude on X, let's increase it to, let's say 5, for example. As for the Z axis, let's increase it to 3, for example. All right. So as you can see, the gun is painting a figure of 8, and that's good. So let's work on the speed. So for the X, perhaps the amplitude on X is too much. So let's reduce it to 3. Let's go back to our sway script. Let's compute the Y component of our value, and let's return it. So by adding the Y component, you can see that the gun is rotating around its axis a little bit. Of course, we can play with these values. So if we make the amplitude much bigger, like 20, and increase the speed, then you can see clearly that the gun is rotating. But we're going to keep these values low to keep the effect very subtle. Yeah, so perhaps for the Y, we can keep the speed at 0.7 and the amplitude at 5. Okay, so I think these values are good. So I set the amplitude to 3, 5, and 2, and the speed at 1, 0.7, and 1. So I'm going to copy these values and then go out of play mode. Then I'm going to go into our character prefab, then paste the values. Now let's work on the UI and add a crosshairs. So I'm going to go to my second scene view, and under the canvas, I'm going to add a new object. So a new empty, let's call it HUD for heads up display. I'm going to press Alt and click here to make the object stretch over the whole screen. Then I'm going to add a new empty object. Let's call it crosshairs. I'm going to add 4 images. I'm going to right click on crosshairs, UI, image. Let's disable recast target. So I'm going to resize it. Then I'm going to duplicate it 3 times in order to create our crosshairs. Now I'm going to select all the images and then choose a color. Okay, now let's open the UI Manager script. Let's add a reference to our crosshairs object. So we created this UI Manager, I believe, in the second or third video. So it was quite a while ago, but we have the methods organized in regions, so it's good. So let's go to the Unity methods and let's add an update method. So in the update method, if the player is defined, we're going to check if the player is aiming. So the character property on the player is our NPC component. So we're going to check if we're aiming. In this case, we'll set the crosshairs to active. Otherwise, we'll set it to inactive. And in the start method, we'll set it to inactive by default. Okay, now back to the editor. So in the UI Manager component, I'm going to assign the crosshairs here. So I'm assigning the crosshairs. And now when we aim, we should be able to see the crosshairs. So I'm going to run the game. Okay, so this is my character. And when I aim, then the crosshairs is going to be displayed. Looking at the shooting pattern of the gun, aside from swaying and recoil, it's clear that the gun doesn't exactly shoot at the crosshairs. So we're going to change this. In our scripts, let's go to third-person controller. And we're going to modify the player controller aiming script. So the player controller makes the NPC look at this position, which is the position of the camera plus 30 meters forward. Now we need to modify this. Instead of having a fixed value, we need to use a recast to get the actual point at which the camera is aiming. So at the top, let's add a header. Let's call it aiming physics. Let's create a layer mask called aiming mask that we're going to use in our raycast. In the update aiming method, we're going to create a ray that goes from the transform position of the camera, and we're going to set the direction to camera follow.transform.forward. Let's create an aim point variable set by default to ray.getPoint with 15 in the distance. Then we're going to perform a raycast with ray and a max distance set to a big number like 1000, and we're going to give it our aiming mask, and we're going to ignore trigger interaction. So if this physics raycast succeeds, then we're going to set our aim point, but we need a raycast hit. So we're going to add it as a second parameter. If the raycast succeeds, we're going to set aim point to hit that point. And in the line below, we're going to call NPC lookat, and we're going to give it our aim point as parameter. Now back to the editor. In our player controller, we're going to set the aiming mask to default. You know what? Let's also set it to character controller in case we're aiming at characters. Okay, now let's do some refactoring. So this sway script, we don't really need it. We only use it to compute the value of the sway. As for a lot of these parameters, like the animation curves, both in recoil and the procedural shoot animation, we can have these in a scriptable object. In our script folder in NPC combat, let's create a gun profile script. So this will be a scriptable object. Let's add a create asset menu attribute with a menu name set to combat/gun profile. Let's add our swaying parameters here. So I'm going to split my editor in two with the sway script here. So now that I think about it, we don't even need the speed to be a vector tree. We can have one speed for all the coordinates of the sway. So in our gun profile, let's create a public sway amplitude and a public float sway speed. We're going to copy this method to the scriptable object, and we're going to rename it to get sway value. It will require a time argument. Let's also add an amplitude multiplier and a speed multiplier. Let's set them to 1 by default. So we're going to replace the amplitude with sway amplitude, and we're going to multiply it by our amplitude multiplier. As for the speed, we're going to use a float and assign it to sway speed multiplied by speed multiplier. And in the code below, we're going to use our speed. So let's rename it to simply speed. Okay, so this takes care of swaying. So another advantage of using scriptable objects is if you have multiple guns, then you can have a separate gun profile for each of these guns, and you will not have to change these values in the inspector of each object. All the parameters will be contained in this scriptable object. Let's open our recoil script. Let's move these values to the scriptable object. So we're going to move recoil angle and recoil angle random. Let's create a header for recoil. You know what? Instead of recoil angle, let's call it max recoil angle and max recoil angle random. Then let's add the recoil curves. First, we need these values to be public. So public float max recoil angle and public float max recoil angle random. In fact, we're going to set every member to public, and let's rename the variable to begin with a capital letter. We can also initialize the curves using animation curve.linear or .constant. So what .linear will do is you will set the time start and the value start, time end, and then value end. So for the attack curve, the value will go from 0 to 1, and for the release curve, it will go from 1 to 0. And of course, we can tweak it in the editor. I'm going to set the sway values to the values we tweaked in the editor for the character. So the sway amplitude, I'm going to set it to 3, 5, 2, and the sway speed, I'm going to set it to 1. And I'm actually going to add a sway speed Y. So our sway speed will be applied to the X and Z coordinate, while the sway speed Y will be applied to the Y coordinate. And you know what? We don't even need these values to be public. So I'm going to replace public with serialized field, and I'm going to do the same for the values of the recoil. So I'm going to set max recoil angle to 3, max recoil angle random, I'm going to set it to 2 by default. Okay, let's change our recoil script to use this scriptable object. So I'm going to add a field in the recoil script, let's call it profile, and I'm going to remove the reference to the sway script. We're not going to use it anymore. So I want to copy the values of these animation curves. So let's create our gun profile first. Let's go to data and let's create a new folder here. Let's call it gun profiles, and let's right click, create combat gun profile. Let's name it blaster. So I'm going to right click on it, then properties to have the inspector of the blaster here. Then I'm going to click on our gun script, and I'm going to copy the values of the attack curve and the release curve. Let's right click on a curve, then copy, then right click on the curve on the gun profile and hit paste. Then let's do the same for the release curve. Okay, now that we have copied the values, we're going to set the profile here to blaster, and we're going to remove the rest of the parameters. So back to our script, we're going to remove these values. So we're going to remove recoil angle and recoil angle random, and we're going to remove the attack duration, attack curve, and release duration and release curves. But we're going to keep the rest of the private variables. Now let's go over the code and replace the values. So instead of recoil angle, we'll use profile.max recoil angle, and instead of recoil angle random, we'll use profile.max recoil angle random. And in the update method, we'll replace the values that we have deleted by the values in the profile. So we'll use profile.recoil attack curve, profile recoil attack duration, and we'll do the same in the release state. And to get the sway value, we'll use profile.get sway value. Another advantage of using a scriptable object is that changes that we apply here will persist even when we go out of play mode. So you can tweak these values as much as you want. For now, I've set the sway amplitude to 2, 5, 2, and the sway speed to 1.2, and sway speed Y to 0.7. So this gives me some decent results. Okay, now NPCs are able to shoot at me more accurately, and the weapon sway adds a little bit of spread to their shooting. And it's also a good thing that we made them shoot in bursts. That takes care of the recoil. So if they shoot for a long time, the recoil will make their shooting inaccurate. So a solution for that is to simply make them shoot in small bursts. A problem with the approach that we're currently doing is if we have an object or a character that's too close to the camera, the player's character will turn and look at them. So we're going to change our update aiming method. In the call to raycast, we actually don't need the max distance to be very big. Let's keep it at 100, and we're not going to make the NPC look at the aim point, or actually we will, but we'll not do it here. We'll do it before calling the raycast. because we want the NPC to always look at the same point. As for setting the aim point, we'll only do it if hit.distance is greater than a value, let's say 2. So instead of making the NPC look at the aim point, we're actually going to manipulate the muzzle transform of the gun. We're going to need to expose the muzzle property of the gun. So let's go to the gun script. We already have a muzzle field. Let's set it to public. Back to our player controller. So the muzzle is a transform, and transforms have the look at method, which is very handy. So we're going to use it and we're going to give it our aim point. Okay, so shooting is working normally, but if we have an object between the character and the camera, but the muzzle of the gun is slightly rotated to make aiming more accurate, as you can see here. Except what we did is we have completely bypassed our sway and recoil scripts. So the player now has a perfect precision, which is not what we want. So instead of directly manipulating the muzzle, so in our gun script, we're going to define two variables, a public bool override shooting direction and a public vector tree shooting direction. And we're going to hide these values in the inspector. In our player controller.aiming script, instead of modifying the muzzle directly, what we're going to do is set the override shooting direction on the gun to true, and then set the shooting direction to aim point minus NPC gun muzzle position normalized. And in the gun script, we're going to scroll down to compute shooting direction. If override shooting direction is set to true, then we're going to return the shooting direction. Otherwise, we're going to return muzzle.forward. So this is only the first part of the solution, because we're basically doing the same thing. If we override the shooting direction, then the gun will always shoot in this direction regardless of swaying or recoil. So we're going to go back to our recoil script, and what we're basically going to do is we're going to apply the recoil and sway effects in the player controller script. So we're going to define a property, recoil and sway angle, with a get and private set, and we're going to set it in the update method. So in fact, it is this value over here. So we're going to set recoil and sway angle to sway value plus our vertical offset. Then we're going to assign it as an offset in our multi-aim constraint. Then back to our player controller aiming script, let's have a variable shooting direction that we're going to set to aim point minus the muzzle position normalized, and we're going to set the shooting direction on the gun to this variable. So we're going to get the recoil component on the gun if recoil is defined. So what we're going to do is, since this shooting direction is in world space, we need to convert it to the local space of the right hand, apply the angle to it, and then convert it back to world space. So we're going to get the right hand transform using npc.gun.transform.parent. If recoil is defined, we're going to get the local direction using right hand.inverse transform direction, and we're going to give it our shooting direction. Then we're going to rotate this local direction by our recoil and sway angle. When we multiply this quaternion with our local direction, we'll get it rotated. Then we'll transform this direction back to world space using right hand dot transform direction with this local direction as parameter. This will fix the problem. So as you can see, the shooting pattern is correct. And if we keep shooting, we're going to apply the recoil. Now we're going to see how to add a bullet time effect. So I did it in the last video. So I added a bullet time effect off screen by pressing 0 on the numpad. We can reduce the time scale, but the only problem is that the physics are a little bit laggy, but we also need to change the fixed time scale. So I'm going to go over it. So in the project settings in input system package, I added an action to the player, which is called slow-mo. This action is a button bound to numpad 0 by default. Then in the player controller script, in the input callbacks region, I added an on slow-mo callback, which is going to be called by the player input script as soon as the numpad 0 key is pressed. So here I could have defined a boolean to know whether we are in the slow-mo mode or not, but instead I'm just checking if timescale is greater or equal to 1. Then I'm setting the timescale to 0.4. Otherwise, I'm setting the timescale back to 1. So if you go to project settings, then time, here we have the fixed time step, and this is the value that we're going to change to have smooth physics. So in the on slow-mo method, we're going to set time.fixedDeltaTime to 0.02 multiplied by time.timescale. Now when we press 0 on the numpad, we should get a smooth slow motion effect. Perhaps on YouTube you will not see the difference, But actually, when you run the build, you will see that this small change that we made is making the physics engine much smoother, because now it is reacting to the time scale and we will get better results than before. If you like this video and the content on this channel, then you can head over to the Ko-fi page of the channel. For as little as $5 a month, you can keep this channel going strong and help me produce more content and deliver much more value to you guys. So form the phalanx, defend the line, and thank you so much for your support. See you in the next video. Have a good one. Bye bye.